Hello, I am Miss Evans, and you are coming to my classroom soon. I'm excited. I'm going to talk about three different math tasks and then some bigger ideas about those things. These are the three tasks that I picked. Cool. This first one is called Hexagon Trains, and I used it at the beginning of the year. I could also use it at the beginning of a unit about linear functions. It is one of those more conventional patterning tasks you might have seen where there are four different things happening. Students are asked to build the next two things, notice what's happening, look for patterns, and write an equation for the pattern. In my geometry class, this was really helpful because it allowed me to surface students' understanding of linear patterns and then connect that into how we write equations for those patterns in different ways. The thing about this task that feels real to me is that students are playing with shapes, but also that they're looking for a pattern and explaining their own reasoning around that. This is a low floor, high ceiling type task, which lends itself easily to differentiation. In one of my classes, we had three different versions of the equation. One that was based more on the slope and y-intercept, so making a table and going from that direction. And then two that were based on different aspects of the geometry. So for my students who didn't quite catch the central thesis of Algebra 1 around slope and y-intercept, they gravitated more toward these geometric explanations, and then they were able to see how the 4x plus 2 came out of the table, which was connected to this concrete pattern building they had just done. Right. The next task is a thing that I made called Translate and Generalize. This is sort of a middle of the unit normal day type task. We're working on congruence and rigid transformations, and I wanted students to practice what that felt like, but also work toward writing rules for translations. What I think makes this task feel real is that students are graphing, and that feels real-ish to me. Then they had to do things with that graph and try to discover a rule. So they started with graphing a triangle, then had to translate it, look at the coordinates, notice what was happening, and eventually get to writing that as an algebraic rule. The differentiation in this task has a lot to do with the pacing. So you may have seen there were 6 pages of this task, and students moved through at a rate that made sense to them. So my students who can't plot points accurately were really going slowly through that first part and being very deliberate about counting and moving. Students who are stronger on that skill moved through faster and got to writing the abstract rule. Students also had some choice in picking arbitrary numbers, deciding how far they were going to move things in order to experiment and test out the rule they were finding. And there was a self-assessment piece of they got to decide if they understood the rule, they could skip toward the last step instead of continuing to practice translating in the middle. And then this third task is interesting to me because it comes one from the end of a volume and surface area unit. This was a poster day that was more of a summative assessment for the class. This also came from a class that was a sub-separate algebra class, which also used geometry skills. And there was really just intense differentiation happening in this task. So we've been working on finding area and volume of various shapes. And for this day, students were divided up into groups, and they had to find the volume of an unfamiliar prism. So either a triangular prism or a trapezoidal prism. students were assigned to different problems intentionally, and they were assigned into groups based on their skill level. So students who were a little bit more comfortable with the calculations had the trapezoid because it looks a bit funnier, the numbers are a little bit more challenging, and students who were less competent with the calculations had the triangle because there are fewer numbers. It seems a bit more straightforward, it's a more familiar shape. Both groups had manipulatives in order to build their prism from a stack of flat surfaces, and then we asked them to generalize from that. And there was a gallery walk and all these different parts to it. What makes this task feel real to me is that students are not only building with manipulatives, but also working on discovering a rule using the structure of prisms. And as I said, this was differentiated by thinking about parallel tasks, that some kids worked on the triangle and some kids worked on the trapezoid. There were also many other pieces within this that scaffolded the work for students in various ways. Okay, so the big ideas that I think about with math tasks in a normal day, in a normal unit, one is this do, notice, generalize thing that you see in the transform it task. I'm asking students to do something. I'm asking them to notice what happened. And then after doing it a few more times, I'm asking them to generalize and make a rule for what's going on. And I've done that several times with different types of skills. And it works for both giving students that practice toward muscle memory that they need, but also the discovery of a pattern and a rule that makes things feel more interesting and I think more real. Self-pacing is a huge element of tasks that I choose. So I'll do multi-stage projects where students work through things at their own pace, and that allows students to rush ahead as needed or be more deliberate as needed. And then choice and self-assessment are also a really big element where students are choosing numbers, students are choosing what color of paper they want to use, they're choosing what color highlighter they want to use, or they're deciding whether they need more practice or if they're ready to move on to the end of a project. In terms of differentiation, those tasks showed an example of the low floor, high ceiling tasks that a lot of us are very used to from BTR Mathland. The element of parallel tasks is also interesting of thinking about how do I construct problems that set up the differentiation between different groups. And that it's not that some students are working on an entirely different thing than other students, but they might have slightly different numbers, different shapes, and so it's all working toward the same idea, but they're slightly different tasks. And then pacing is a differentiation strategy as well because it allows some students to move ahead while others work through more deliberately. Cognitive demand is this thing that we talk about in BTR all the time, and I think sometimes we think that it has to be a big Dan Meyer 3-act, do this thing and then discuss it day. And the reality is that it's not going to be that every day, especially I work in MCAS prep land and we can't do that every day. But I do incorporate these strategies of always moving from the concrete to the abstract. So whether that's we're building with shapes or we're graphing a thing, and then eventually we're getting to an equation and a pattern. Having students notice and generalize, this keeps this element in of they're doing the thinking, they're doing the reasoning, they're finding out the big mathematical ideas, not giving away the punchline to them. Even on a fairly boring day, we're showing things in multiple ways, and students are encouraged to push from basic words they might have learned in elementary school toward a higher level of vocabulary. And I'm always, always, always asking them why. Why does this work? Why does this make sense? Why are these two things the same? Why does this show the same thing as that? And that's sort of how I keep